Okay, our final example, we're also going to use that fact that orthogonal vectors get us a dot product of 0. Again, another way to practice coming up with, or practice the dot product. So I'd like you to find a vector that is perpendicular to u. In this case, we're talking 2 space here, so it's 1 and 4. Now, we're going to come up with something, and then we will test it by doing their dot product. So what we'll do here is we'll say, okay, we know that 1, 4 dot some vector, I'll just call it AB. Well, if they're perpendicular, then we know their dot product is equal to 0. So let's do the math here. If we actually apply the rules for dot product, it's x's multiply the x's, so 1 times a is a, and plus 4 times b, which is 4b, equals 0. So we know that there's lots of vectors that are perpendicular to 1, 4. We just need to pick one. We know that they have to have this property of a plus 4b will equal to 0. Now we can shorten it if we wanted. We could do this. And then all we'd have to do then is pick a value for b. So what if b equaled 1? Then we would have a equals negative 4 times 1, which is negative 4. So therefore, our vector would be negative 4 times 1. Now we can check that, and I'll sort of check that over off to the side here. So 1, 4 dot negative 4, 1. Multiply the x's. 1 times negative 4 is negative 4. 4 times 1 is 4. And sure enough, it's 0. So I know that those two are definitely perpendicular. But there's lots of ones, right? What about if b equaled 2? Well, then a equals negative 4 times 2. So that'd be negative 8. So therefore, we'd have a new one, negative 8 and 2. Let's check this one in our head. Okay, so it's 1 times negative 8 is negative 8. 4 times negative 2 is 8. So negative 8 plus 8 gets us a 0. And really, if we stop and think about it, these two vectors are both perpendicular because if you look at them, they're actually scalar multiples of each other. What that means is this one is negative 4, 1. Negative 8, 2 is just twice as long, isn't it? Like if you take your a value and multiply it by 2, you'll get your negative 8 and your 2. So of course this is perpendicular, it's just longer. So there's lots of possible answers here. Now, I'm calling this the long cut. Oops. Long cut. Because I'd really like you to look at this answer here and think about why this works. Okay, first off, you'll notice that, of course, these numbers are essentially the same as these, but in opposite order. So we started with 1, 4, and you'll notice that these numbers are 4, 1. We need the opposite order because we need them both to equal 4, right? So 1 times 4 and 4 times 1 gets us a 4. Then in order for them to add up to 0, one of them has to be a negative. So there is a shortcut. The shortcut is this. The shortcut is if you're given a vector and you want to find one that's orthogonal or perpendicular, simply switch x and y and make one of them negative. So let's try this with a different example. What if I gave you a vector negative 7, 1, and I wanted you to find one that was perpendicular? Well, first thing we'll do is switch them. So instead of negative 7, 1, we're going to make it 1 and 7, but then we got to make one of them negative. So one that's perpendicular would be 1, and if we just switch the order, it'd be this. But since this one is negative, what we could do is make that one negative of a negative, which makes it positive. Again, off to the side, you can double check this, do their dot product. So multiply the x's together is negative 7. Multiply these plus 7 equals 0. So that's just our check. Now, who said that we had to make that one the negative one? So we could have done this. This one would work as well. Switch the x's and y's, leave the negative 7 as negative, and make the second one negative, or the first. So now that's going to work as well. Again, we can do a test on these, that these are perpendicular. So negative 7 times negative 1 is 7. 1 times negative 7 is negative 7. That equals 0, and that works as well. So that's the shortcut if you're just asked to find some perpendicular vectors. You can just switch the x and y's and make one of them negative. Now, you can also make any scalar multiple of these. We saw that as an example here. If you just take any of these and multiply it by 2. So for example, if I multiply this by 2, I'd get negative 2. And multiply this by 2, I get negative 14. That is going to be perpendicular to this as well. Again, just do the check. Multiply, we get 14. Negative 14 equals 0. So it's perpendicular. So I'll give you a second to try on your own. Let's do 2, negative 3. So I'll ask your teacher to pause it for a second and write a couple of possible perpendicular vectors. So here are a couple answers. Sorry, I forgot to switch them. So switching them, and I made the negative 3 negative, so it becomes positive. Or we could have done this. Or any scalar multiple of those. That would be perpendicular. All sorts of different ones. So the question is, will this same shortcut work in 3 dimensions? And let's show you that. So we're going to start with a 3-dimensional vector here now, 2, 4, negative 1. And I'm going to show you one that's perpendicular. And then I'll see if you can notice the pattern. So this is perpendicular. It's kind of a cheesy way, but it works really nicely. First, let's just double check that in fact it is perpendicular. So do the multiplication. Negative 8, positive 8, and the last one is 0. So of course that adds up to 0. Now why is it cheesy? Well, if you look at it, what I did was the first 2 numbers, I did exactly what I did in 2 space. So I switched the order and made one of them negative. I know that will work. That will get me a 0. And so the cheesy part is I just made the third component 0 so that when I added something on, it would still be 0. So it's clever, but there's lots of other ones that would work, but this is the easiest shortcut. Again, it doesn't have to be those 2. So if I'm going to go with 2, 4, negative 1, I'll stick with the first 2, switch those, This time, instead of making the 4 negative, I'm going to make the 2 negative, and then make the third one 0. That is going to be perpendicular as well. But it doesn't have to be those two, the first two. It'll work if I choose this one and this one. Switch those and make that 0. So if I switch those, the negative 1 comes out front, make this one 0, and do the other one 2, but of course one of them has to be negative. So why don't I make that one negative? That's going to be perpendicular. Or keep these, but this time I'm going to make this one negative. So negative of a negative makes that positive. Put a 0 in the middle. And put that. Or again, I could pick these two and make this 0. And so this will work as well. 0. Switch the last two. And I made the negative 1 turn into a positive 1. Or make that 0. Put the negative 1 there and make the 4 into negative. Each of these would be scalar multiples. Or sorry, each of these would be perpendicular. And then scalar multiples of any of these would also be perpendicular. So I could take this one, for example, multiply it by 4. So negative 4, 0, 8. Or negative 8, excuse me. That also would be perpendicular to that.